stage a Java rockstar, Arun Gupta. Arun is an international focal point for all developers and tech communities, and today is going to share with us an experience in how help organizations become more scalable and competitive. So give a big round of applause for Arun.
Fantastic. Thank you so much. I'm very excited to be here. My first Codemotion was Codemotion Rome, where I keynoted back in 2014. And that's the original Codemotion, so I feel like, I need to touch the feet over there. Thank you for inviting me here at Codemotion Madrid. I'm super excited. My name is Arun Gupta. I am part of the AWS open source team. I'm here all day, so if you want to talk anything around open source, anything around Kubernetes, anything around containers, anything around running, I would love to talk about running and all sorts of fun stuff. This talk is about speeding up innovation. How do organizations need to scale? They need to deliver at a fast pace to stay competitive. They adapt different methodologies, using things like continuous delivery to deliver faster. They're adopting cloud-native architectures to be able to scale. And then they're using principles like chaos engineering to build resilient systems. So this talk is essentially, is a collection of my discussion with customers around the world at Amazon and at previous companies, and how and what we have learned over the years in order to speed up innovation for your organization. So let's see. There are 3 stages of innovation if you were to think of it. The first one is that you want to build something really fast, really quickly, put a stake in the ground, fail fast, and recover. That's sort of the thought process you want to think about it. And we'll dig into that. The second phase is where you want to build something, let's try this, something really large, something that scales very well so that you can reach the masses. Okay, that's the second stage. And then there's a third stage here where, which is more deadline driven, where these companies who are server huggers, they want to hold on to their data centers, they're migrating to cloud. And these are deadline driven because essentially, if you think about, there is 2-3 year lease for a data center, and when that is expiring, that's the time you start thinking about it. Does it really matter to me? Do I want to keep my data center or do just move to the cloud? So essentially, what this gives you is speed, scale, and strategy on what you need to do to innovate and really get on an accelerated path over there. First thing, you don't hire a VP of innovation. You essentially, as Chad was saying, you hire really smart people and you get out of their way. You just empower them. I've seen some of the LinkedIn postings, and I get contacted by that, become a VP of innovation. So what does that mean? There is innovation needs to be enabled across the org, essentially. That's the way you want to think about it, okay? So with that quote, let's see. What is a fundamental unit of innovation? How do you measure the innovativeness of your company, okay? It is basically time to value. And what time to value means is that I, as a developer, built a feature. How long does it take for me to have that feature being realized by customers? Does it take months? I pushed a feature, 6 months later, as part of a monolith, it's going to be available to my customers. Or does it take days? Maybe it spins out on a weekly cadence. There's a weekly build that goes out. Or you have something called as a continuous delivery pipeline, where every change you push automatically builds your software and releases it to the customers. The faster your release cycle is, the faster your customers can realize it, and there are lots of advantages for that. Okay? So how does that work? Now, one thing that we realize is there is no economies of scale in building software. There is economies of scale, for example, when you're running in the cloud, but in terms of software, we have realized over the years that the smaller, the better. The more the focus it is, the faster it builds and the faster it runs, okay? Now, why so? What are the advantages of that, essentially? If you think about it, what it gives you really is, if I can read my slides here, it gives you automated, because you want to do faster, there are some key components that you require for building those lots of small changes. You need to have automated continuous delivery pipelines, because doing those changes by hand is going to take a while. That's where you want to have those automated delivery pipelines so that every change automatically built and move on. You need things like tagging, which allows you to tag the versions. You need flagging. You need to have A/B features where you can say feature flags. Turn this feature on, turn this feature off, to certain types of audience. You need to do canary testing. You need to do A/B testing. Things like that where you can say, I'm going to release this new feature to 1% of my traffic coming at Tuesday, 11 a.m. that is coming from a certain user agent, but maybe a mobile device or a browser. That way you start testing it, and then you expand from there based upon your health metrics on how that's working out. And then the important part really is the build of your software needs to be really cheap. Because you're doing it so many times, it's really important that the build is happening rather fast. So essentially what we are recommending is take your monolith and split it across multiple microservices. And why would you do so? Well, the reason you would do that is because then the monolith that you have built over the years, which has probably a big build, takes a while to go, takes a few hours maybe as you're running your tests, etc. If you translate that into a microservice-based architecture, then the build is fast because the focus is there, you're possibly following the domain-driven design and all those concepts, and then your service can be built faster and can be put into production faster. Is super important that that's the focus that you're gonna take a look at. Now, if you are doing that one thing at a time, what are some of the advantages of that? Well, because with each Git push, essentially you are building a delivery pipeline, the feature is released, so it's a lot easier to tell if the build is broken, or rather identify the culprit that broke the build. And because you can identify the culprit using the deployment pipeline, it's a lot easier for you to say, because the build is broken, stop the build, or be able to roll back, essentially. So this is some of the technologies that we have seen consistently all across. You can also measure time to value. Now, that's the key component that we're talking about over here. So is it one feature that I've built, and it's going to take 6 months unless it gets deleted by somebody else? Hopefully that feature will see the light and customers will be able to give feedback to me, as opposed to doing the microservices architecture where I build the feature this morning and in the evening I can see the feature is already live and customers are accessing it and providing feedback on it. So that's sort of the mentality and the thought process you need to have. Amazon.com went through this similar design change, back in 2001, 2002. Amazon.com was a one big monolithic application back in 2001, and it would take a while to change one particular part of the application. What that means is really that I just want to change the wheel of the car, but you can't do that. You just need to buy a new car altogether. And that's sort of what led to the whole thought process that, let's take that one big monolith and essentially break it apart into multiple microservices. So we went through that journey, and back in 2009, this is sort of what our architecture would look like. This was completely microservices-based. Each dot that you see, and by the way, remember, this is 2009. So each dot that you see represents a microservice, and they're all talking to each other using well-defined protocol, HTTP in most of the cases. In this case here, and they're really talking to each other using well-defined interfaces, okay? Another thing along with that we did at Amazon.com is sort of the two-pizza team. The usual running joke is, what kind of pizza? American pizza or European pizza? And what if there is a person who eats 4 slices in a pizza? So the usual thought process over there is 2 slices per person in a pizza, and a large pizza. So the idea is you want to build a team that can be fed by 2 pizzas, okay? So we're really looking at about 8 to 10 people. And why so? That team essentially has full autonomy in terms of what needs to be done for that service. They have well-defined interfaces. That's what they need to honor. But behind the scene, what is it that they need to do? What language, what stack, how to scale it. And one of the key principles over there is you build it, you run it. So you are responsible for all of that as well. So it really brings that DevOps mentality to your mindset over there, essentially. So what we did is essentially, think about, how does your deployment pipeline look like? You have this one big monolithic application, lots of different members working on it. They're creating all of these services, and they're all going through your deployment pipeline. So your goal is to really, remove the bottlenecks over there, or unbottleneck the architecture over there. So the first step that you do is, okay, I'm going to follow the two-pizza team architecture over here, and I'm going to decompose for agility. So this really allows me to kind of start splitting my team into multiple, one big team into multiple teams, each team with a very clear focus over there. Now, you have unbottlenecked the development, but what you need to do now next is unbottleneck the architecture. So then we say, you know what, all of these teams are really not putting into one big service. They're all creating their individual services, and these services really need to be able to talk to each other. And then really the last step that is remaining for you in that case is, how do I unbottleneck the deployment pipelines? And that's exactly where you say, each service team going to create a service, and they're going to have their own deployment pipelines, so they can have that agility and ability to innovate at a lot faster pace. So how do we get there, basically? I mean, the first measure, as we said, is time to value. So we need to measure how long does it take to get over there, okay? Now, if you're a manager, then you need to start thinking about that, how do I measure time to value? And it's not about getting, measuring how fast you are, but it's all about setting that baseline and saying that how I'm gonna get faster. Because it's a very psychological thing if you think about it. Once you start measuring, once you have the baseline, then you start improving upon it. If you don't even have the baseline, you don't know what is the area for improvement over there. So that's the first part. You need to kind of start measuring what is the time to value for everybody in the team. Then the second thing is, we need to do small things really quickly. You don't want to go through the most complex project that you have and then saying, I'm going to start breaking this apart, and I'm going to convert this into multiple microservices, and I'm going to build the deployment pipeline. You always want to start with the project that is not in the pipeline, not sort of becoming the bottleneck for you. So you start a project that is smaller in scope, you kind of start converting that into microservices, get your experience, get a feel, what does it mean, get some quick wins, and then you get a feel that, okay, now I can move forward with projects that are more critical to my customer workloads. And last but not the least, you need to make sure that you measure the cost per deploy. Because the builds need to be cheap, you want to start measuring your CPU hours, your memory hours that are being utilized, particularly if you're running in the cloud, because you're getting billed for that. I was talking to a team, and they were saying that, hey, we release once every 6 months, and every 6 months, and then I asked them how many number of tickets are filed for that particular release. They said about 600. It's like, wow. The way you want to get to, or where you want to get to, is essentially with each Git push, if need be, file an automatic ticket, and that ticket automatically migrates through different stages as your build is progressing, and that's what it should be. Also, what that means is there should be no meetings. Well, there are meetings, but they're not in the flow of releasing your software. So essentially, you are looking at your entire development life cycle and unbottlenecking on the places where it could potentially delay the entire infrastructure. So what are some of the advantages over there? The usual ones are, you can see that you have a shorter MTTR, you have a better MTBF, which is mean time to recovery, and mean time between failures. Because essentially, what that gives you is the ability to release faster. The more features you have, sometimes it's very time sensitive that Thanksgiving is going on or Christmas is going on. My feature is going to be available. My discount is going to be available for next 1 hour. Think about that kind of agility. How can you make it faster? And then there are usual advantages over here. One of the things that we can't really quantify sometimes is happy developers. That is super important. There have been surveys which talks about what keep developers happy. And the survey says, it's not the job, it's not the promotion, but it's this intrinsic capabilities that developer builds something and customer is able to use it. And that's super important for the motivation and the morale boosting of the team itself. Something else that I want to talk about on this topic is also something called as DevOps State of the Report. And this report has been released for the last several years. And it basically takes, it's a survey, this time around 2019 survey was survey of 31,000 professionals, and it took their companies and divided them into 4 different categories. So elite was the top category, and then there is high, medium, and low. And it basically qualified them in terms of what is their deployment frequency, what is their lead time to change, time to restore service, and change failure rate. So those are the features that it basically kind of measures them on. And the stunning part is, if you look at the difference between the elite and the low performers, is significant, is huge. And then the report also talks about what are the practices that are followed by the elite performers. Let's look at some numbers here. So now look at this. So here it talks about that, it talks in terms of throughput and latency. It basically qualifies on those two particular criteria. But if you look at it, for example, the elite performers deploy 208 times more than the low performers. And that's the reason they're able to achieve that agility, and that's the process that they're following, the microservices, the continuous deployment part of it. All those are standard part of the processes. They are able to, their failure rate is 1/7, even though they're deploying faster, but their failure rate is a lot smaller because they're able to catch the error right where it happens because of that entire deployment cycle. Automatically sending an email that, or blocking the build because it's failing the usual test for me. So think about it, that essentially what you're looking at is how do you do simple things quickly, really fast, and automate the heck out of it. That's sort of the main process over here. Let's look at the next part. Now let's talk about what kind of architecture we need to build that innovation, essentially. So these systems are highly scalable, and you want to make sure that they're accessible in case your app goes popular overnight, so that way it can scale up automatically. That's an important part of it. They're distributed for availability. At Amazon or at AWS, we have this concept of a region, which is a physical location around the world. And within a region, we have multiple availability zones, where each availability zone is a cluster of servers within that geographical region. And these availability zones are separated by tens of hundreds of kilometers to give you that resiliency and disaster recovery and things like that. At this point, we have 22 regions around the world with 69 availability zones, with plans for 9 more availability zones announced in 3 more countries. That's how our customers build these resilient applications. Netflix, for example, they run on 3 regions across the world, across 4 availability zones. And that's exactly how they're giving a high throughput and, more importantly, a low latency as well. That's an important part of it, okay? Now, these systems are cost optimized for high utilization. That's the difference between data center and cloud. If you think about your data center, you will have a lot larger number of machines, but the utilization would be low because you're optimizing it for the peak capacity. In the cloud, if as a matter of fact, you may have a more number of machines during your peak time, but during your non-peak time, the machines would be a lot lower. But you're not paying the cost for that. And that's the whole premise for moving to the cloud, essentially. And last but not the least, this is where cloud-native architecture comes in, the elasticity part of it. Your workloads increase any point of time and decrease any point of time, and so does your number of machines that are serving that request. So let's look at the sort of cloud-native principles. What are the key cloud-native principles that we'll talk about over here? The first and the foremost is you're not really looking at, hey, I'm going to buy this data center, I'm going to have the hardware ready up in there. It's really pay per use. Whatever you're used in that hour, in that month, is what you're going to pay for. That's an important part of it, because that way you can really focus on your core competency and not do the undifferentiated heavy lifting. Self-service, and that's important because, for example, at AWS, you can go and say, I want a database, give me an RDS. I want a Kubernetes service, give me Amazon EKS. Now, I want an IoT, I want mobile authentication, whatever you want, those are all self-service. There is no need to file a ticket, essentially. We talked about how it needs to be globally distributed across the world. We talked about high utilization. And also, the key part over there is immutable code deployments. If you're building container kind of services over there, or serverless, which we'll talk about in a second, but you're not really updating your code. You terminate the code, remove the code, and then bring in the new container image to replace it. And that's sort of the whole immutability concept that is important. So the question that customers ask us all the time is, all right, so I get this concept. I buy the dream of microservices, but what should I do? Containers or serverless? Or probably both. And we have customers, a lot of customers that are in all the camps over there. So let's talk about it a little bit. At Amazon, we talk about this concept of shared responsibility model. And what that means is that it is AWS responsibility to take care of the data center, the hardware, the virtualization layer that we provide, including the physical security of the data center. That's our responsibility. And the tools on top of that, we provide you all the services and all the ways to store your data, encrypt your data at rest and in transit. Those are your responsibility. That's sort of how we split the responsibility between customer and what AWS provides. And if you think in terms of operational responsibility here, that's sort of how we draw the chart at AWS. Whether it's compute, databases, storage, messaging, and we have this for all sorts of services, we provide a wide spectrum in that sense. If you feel like that, hey, I need to run my own database, I need to be in control, you can look at the left end of the spectrum, where you can bring your own software, open source, whatever kind of software, bring it to EC2, run it over there. Or if you think that, hey, this is not my core competency, I just want a database to be provisioned, somebody to manage it for me, I don't have time and resources and skills to download, install, patch, upgrade, make sure CVEs are addressed, let somebody else do this for me, and Amazon is good, so then you go on the right end of the spectrum. So essentially, you go back and forth. And generally, when we look at serverless and containers, the line is hard to draw, and each customer conversation is very unique in that sense. That what is, we generally tell customers that don't get carried away by the golden hammer. So the important part is to understand what is it that you want. So let's talk about sort of the way we look at sort of the serverless landscape. We really think of this as really 4 key tenets. The first one is, from your perspective, you are not managing the infrastructure. Get the concept right. Serverless does have servers. They do. Not the ones that you are managing. Somebody else is managing them for you. That's an important part. So there is absolutely no infrastructure that you need to manage. That's the first tenet, essentially. The second tenet is, if your app gets popular and if you're using functions, essentially, or Lambda, and the scaling needs to happen, the app automatically scales. You can build your application like that, but with serverless, that scaling happens automatically. Then you're looking at it, when you are provisioning a Lambda function, essentially, then you're saying, okay, here's the CPU, here's the memory, and the function ran for 77 seconds, and that's all I'm going to pay. So you basically pay for value. You don't even pay, as a matter of fact, for storage in the cloud. Let it sit there over there, but you only pay for the execution time of it. That's super important. And then high availability comes as part of it. Once again, you can architect your application to be highly available, but once you deploy a Lambda function, we make it highly available for you. We make sure it's running across multiple availability zones and so on and so forth. So let's look at some of the services that AWS offers in terms of serverless. We offer them in a wide variety of ways, whether it's storage, whether it's database, whether it's compute. But the core concept that developers mostly interact with is really the compute part of it. Okay, so let's look a little bit deeper into the compute aspect. Now, in compute, we essentially have 2 services. You want to bring your Lambda, you want to bring your Java function, Go function, C# function. You want to bring that function in? Sure, bring it in, deploy it into AWS Lambda. We have some of the most enterprise customers running Lambda at a huge scale. Take an example of FINRA. FINRA is doing 500 billion, that is 500 billion validations per day using Lambda. So that's the scale that Lambda operates at. And it's all sorts of compliance and everything available. It's a foundational service available across all the regions. So if you want to go that route, sure, AWS Lambda serves you well for that. Or if you want to go the route where you say, I've already containerized my applications, that's where we provide you AWS Fargate. Again, AWS service, but it gives you the ability where you can leverage the containerization that you've already gone through and then run it in a serverless way. So on the right, what you see, on the left, what you see is the Lambda, and on the right, what you see is what we call as serverless containers, or AWS Fargate. Well, today, Fargate supports only ECS, which is our container orchestrator, but we are working on making that implementation for Kubernetes as well. So essentially, you can bring your deployment spec, which is Kubernetes, and say just run and scale the servers. I don't care about my whole cluster concept. So let's go a little bit about in terms of comparison of operational responsibility. If you look at it, essentially, There is AWS Lambda, where you really have to do nothing. Just bring your Lambda function, drop it as a zip file, and it runs. Comes AWS Fargate, where you at least have to containerize and bring that container to run it at scale. Then you can similarly go down the layer, ECS, EKS, and EC2. So it really kind of defines what is it that you need to do, what is it that AWS needs to do, and that's sort of operational responsibility concerns over there. Okay. As I was saying earlier, it's super important that you don't get struck by a new shiny toy. That, oh, I mean, I was meeting lots of our customers last week, and pretty much the question that I asked all the customers is, sure, you want to do Kubernetes, but why? And they were like, yeah. And that's a discussion that you need to have. So don't get struck by a new technology. Don't think of it as a golden hammer. Always think about what is the pain point that you are trying to solve with this. If it's agility, if it's open source API, if it's saying that, hey, you know what, I have more number of developers to hire, sure, I get that, I buy that. And that's important, because that's how you're going to deliver faster time to service. You may want to do this on-prem or in the cloud or a hybrid environment, whatever you want to do. But make sure you document those decisions so that you're not struck by it. Let's talk a little bit about observability, some of the epidemic failure modes, and a little bit about chaos engineering as well. So the definition of observability really comes from the fact, there's a paper written on systems engineering, on control systems, actually, back in 1961. And really it says that a system is observable if the behavior of the entire system can be determined by only looking at its inputs and outputs. That makes sense, that, hey, I gave these inputs, and I got these outputs. That makes sense. I can look at it. But if things break, that's when I need more observability. That's when I need to kind of dig into the system and say, tell me more details, what happened. And more often, you need that information, okay? So if you look at the systems that we are familiar with, let's start with monolith at the bottom layer. It has some logging enabled over there. It talks about what happened over there. It generally does not give you why that happened over there. So it has some observability, or at least because you're figuring out what's going on behind the scenes. Then the next layer is where you have tracing enabled. Monolith, but tracing enabled, because now you're able to see that, all right, I got the what, now I'm getting the why as well, because through the trace that I'm sending through my monolith application, I'm able to identify what my core stack look like, what my thread dump look like, how much memory is being utilized, because that's what tracing can actually help you give. And then as you go up the stack, then you can see that microservices or functions, essentially, or serverless functions, can give you a lot more control over in terms of tracing. Because you have already taken your one big monolith, split into multiple microservices, you can enable tracing and exactly figure out in which order the microservices are invoked. And then because the scope is small, that gives you the ability to pinpoint the error and potentially fix it at a faster pace. And that's where concept like MTTR comes very important, mean time to recovery, because you're able to identify the problem faster, and that gives you the ability to fix it faster as well. So how do we monitor and control all of these microservices? Because the system is inherently a lot more complex now. Now, if you think about a bit of your microservices architecture, then essentially what it tells you is that you are using a wide variety of languages. And if you want to do the logic, that typically needed for observability, so things like, you want to do routing logic, discovery logic, deployment logic, you can't start baking that into your microservice. Why? Because then your microservice becomes a monolith, like a bloated microservice. That's not the intent. So the model that is being utilized quite heavily these days is where you're saying, all right, I am going to take that microservice, and the microservice is going to stay focused on my application logic, and all the concepts that I talked about, I'm going to move that out, because those concepts are independent of what language is being utilized. And that concept can sit in my sidecar, for example. So think in terms of Kubernetes, for example. Kubernetes has a pod. Pod can have multiple containers. It can have like main application container, and then can have a sidecar container. Envoy is a popular sidecar container that is being used. Envoy was created by Lyft, by Matt Klein. And they're using it at a very high scale, essentially. So that's a popular sidecar that I've seen customers using, essentially. Now, imagine your hundreds and thousands of containers running in the data plane. That means with each application, you have a data plane with an Envoy running. So that's a data plane of Envoy. So what you need is something on top of that to manage that data plane of Envoy. Well, Istio is a popular data plane that we have seen customers using it. But once again, the more I talk to customers, I realize for hundreds and thousands of containers, Istio is hard to manage. And they were actually getting blocked by the scalability of Istio. Well, that's where we also launched a service called as AWS App Mesh. And App Mesh gives you a service mesh using upstream Envoy, essentially, and gives you that scalability, not just for Kubernetes, but for a wide variety of systems. So highly encourage you to take a look at that. Let's talk a little bit about failures. The failures could be independent, where something happened and doesn't happen again. More often than not, they're correlated. What that means is, if something happens, then this dies and that dies, and so on and so forth. And in certain cases, they're epidemic. So let's take a look at some of the failures that we have seen. If you were unfortunate and you were running an unlucky version of patch level for Linux, you got a Linux leap second bug, for example. You have an agent running on all of your nodes, continues to work fine, but then one day there is a memory leak in the agent, and that really brings your entire system down because the agent is running on each of the nodes, essentially. You could also think about cloud or zone failure. Whatever cloud you're running on, that cloud came down for whatever reason, or the region where you're running in, that came down. That can happen. DNS failure can happen. Security configuration is more common than you would expect. Or somebody just changed the firewall rules, or somebody just changed the security group, and the port is no longer accessible or available. Okay? Now, if an epidemic happens, what do? Well, we quarantine it. So what we do is we start quarantining it, and then how do we solve it? Well, we start looking at solving these problems. If you are running sort of a Linux-based workload, and you want to make sure that this doesn't happen to you again, then you run some of the workloads on Windows. So Windows, actually, the code base is sufficiently similar, but now the fact that Windows also supports Linux, that makes the thing a little bit spinning in my head. That what am I using? Am I using Windows on Linux, Linux on Windows? And what is the code base? All that sort of stuff happening. So if you look at the different examples over here, let's take a DNS failures. I want to make sure that I have multiple DNS routing mechanisms so that if one fails down, the other one is available. So the key part, if you want to think about, is if you were to contain an epidemic, diversity is important. Let's take a deviation for about 30 seconds. Look around you. Then this is a request to all the male members. Look around you. How many non-male members are in the audience? That's an epidemic in the IT industry. And I think that we need to control. And I'm not just talking about females only in this case. Yes, there are a few ladies here, particularly hats off to the Codemotion team. It was all ladies driven, so fantastic job, Kiara. But I think this epidemic we have to control. We need more diversity, not just ladies, but I'm talking really about people from different skill set, people who are starting new in the industry, kids. Codemotion Kids is a fantastic example of that. Veterans. Think about LGBTQs. So all sorts of people, we need to kind of contain that epidemic to make sure that we stay relevant here. So let's switch gears and talk finally about the strategic aspect of it. Now, Volkswagen is working with AWS to bring out, let me get the numbers right, to bring out more than 30,000 locations of over 1,500 suppliers and partners in the world on the same cloud. And that they're going to do essentially by making sure that they're working across the board and getting rid of their data centers. And this service, when they're going to build, they're going to share it with other manufacturing platforms as well. And that's the kind of wide sweeping changes that we're seeing across the board on how and why customers are going onto the cloud, because they're seeing some real benefits of this. There's a paper written on this. I recommend reading that. But essentially, what's happening is these migrations are now underway for travel, for finance, for healthcare, for manufacturing, across the board. We're seeing a lot more customers every day, literally every day, who are getting rid of their data centers and migrating to the cloud because they're seeing the agility, the breadth of deployment, the cost savings, the global deployment, the elasticity, all these benefits that they get as part of moving to a cloud. And I really call them as A, B, C, D, E. So if you were to think about it, agility, breadth of deployment, cost, global deployment, and elasticity. That's sort of the ABCDE of why customers move to cloud. So moving to cloud computing requires an explicit effort. Typically, the way customers start is they're going to start with, OK, I'm going to do a lift and shift, get rid of my data center. So that's sort of my first step. Then they start looking at it, OK, I've done the lift and shift. Now, how do I start leveraging? Why do I want to manage my own MySQL database? I'm going to get rid of this, and I'm going to use MySQL service, which is a managed service by AWS. And then slowly they start evolving and start building cloud-native architecture. And that's sort of the direction where we are seeing customers are kind of going through that journey, and we are very much working with a lot of customers around the world for help making that happen. This brings up another point. How many of you have a backup data center? It's just a few hands. All right. Now, how many of you fail over apps to it? That you actually practice, oh, thing happened, and we're going to try failing over app to our backup data center. Oftentimes, very rarely, because the auditors make us do it. More often is none. We have never done it. Yeah, we have a backup data center. So the part to think about this is, it's really called as an availability theater, because you have a backup data center, but you are really not trying it. Now, that becomes your weakest link. But the most important link when a disaster recovery needs to happen. So if you have a backup data center, make sure you are explicitly failing over to that backup data center and testing those things on a daily basis. So a fairy tale, once upon a time, in theory, if everything works perfectly, we have a plan to survive the disasters, which we don't even know of. If you don't practice those disasters in production, they will happen, and you would not know how to react to them. So it doesn't work that way. Lots of examples of that I want to run through. But essentially, think about you forgot to renew a domain name. This was a SaaS provider. Think about, hey, the IT guy who got the SSL certificates joined 5 years ago, but he left, and he forgot to set a reminder. 10 years later, security certificate expired, and the domain is not accessible anymore. One of my manager's friend, he was running a data center in his garage downstairs. And we realized that, oh, by the way, when water gets into computer, it doesn't work. Even after water leaves the computer, because it leaves some sand over there, it doesn't work. There are reasons on why customers are migrating to cloud. That's an important part of it. The most important part is, you can't predict a failure. Failures are inevitable. They will happen, whether how expensive or how cheap your hardware is. Packets will fail. So your role and your goal essentially is to identify when those failures will happen, and if they happen, which they will, then legislate against them and recover from them fast. So fail fast and recover and move on. Think about a use case where your service needs to access data from a cache. What if the cache goes down? Do you want to throw a 503 to your customer? You don't. Or a 404 to your customer? You don't. Then all you do is you just migrate from the cache service is down. My fallback plan is I'm going to go directly access the database, get the results back, and display the results. Maybe a higher latency, but it's a graceful degradation. So think in terms of that, on how you're going to build that thought process over there. By the way, Chris Pinkham was the guy who built original EC2, and he kind of gave this code that you can't legislate against failure, just focus on fast recovery. So the way we are looking at it is really, in the past we had disaster recovery. We would fail over to a backup data center. Chaos engineering is a very common principle that a lot of customers deploying across the board. And hopefully in the future, we will look at it where chaos engineering is not just a fancy principle or a concept, but it's really being applied across the board as you are building software. Those principles are important. Maybe give a quick rundown of how the history was done. Back in 2004, Amazon used to run, and we still do, run game days. So whenever we launch a new region or a new service, we do game days, where we randomly go and terminate services and see how it's going to react, because that's what's going to happen in real life. Netflix happened. They started building their Chaos Monkey, and they released a big set of tools around that. That became popular. Colton Andrus, who used to work at Amazon, then Netflix, founded a company around it, Gremlin. And that became extremely popular. So that's sort of the history of chaos engineering. But quickly run through this. Essentially, what you're looking at is 4 different layers. You are looking really at infrastructure layer, that are you deploying across multiple availability zones and regions. You are thinking about how the switch is going to happen, what my graceful degradation plan is going to be. You are thinking about how my application is going to be resilient. If things break, do I have enough number of pods running to be able to scale up and meet the workloads? And then last but not the least, super important part is about people. Make sure people are aware that chaos engineering is happening, things are breaking, because that communication is fundamentally important. Let me skip through a couple of slides here, which I sort of repeat here. This is the survey that I want to leave you with. Usenix has a paper on this from 2014, I believe, where they say 92% of failures in your system, the catastrophic failures, can be prevented if you take care of your code itself, and there are known failures in your code. So you just need to practice more chaos engineering so that it helps you build those resilient applications. Another important part is chaos really doesn't cause any problems. It's a lot of a mindset part of it, but it helps you reveal those problems. Because no matter what you do, that chaos is going to happen in the real world, so better be ready. This is a quick rundown of what the chaos engineering mind map looks like. There's a URL at the bottom here where you can look at it, people, tool, processes, everything around chaos engineering. I'm here all day and happy to talk about anything and everything around chaos engineering. So really, the last slide over here is where we say, because you are migrating to the cloud, it gives you the ability to simulate cloud chaos engineering a lot more easier. It has the tools. We have guidance for financial services sector where we have done that. Okay, how do you build resilient applications around using the principles of chaos engineering? So let's go back here. You're really, in order to be innovating faster, what you're really looking at is, how do I make sure that I have the speed, I have the scale, and I have the strategic movement which allows me to continue to innovate? End of the day, your time to value to your customer matters, because that's what helps you make a successful business. Thank you.